Now we are going to see trigonometry. Trigonometry. So, trigonometry. We're going to explain some terms, some facts of the trigonometry concerning trigonometric ratio, trig identities, double angles, and compound angles. Okay, the quadrant also is very important. Now we are going to see trigonometric ratio. Trig ratio. Now let's assume we are given a right angle triangle. Assuming we are given a right angle triangle. This is the angle 90 here. Let me name it A, B, C, and the angle is given with the right angle is given with an angle subtending an angle of theta degree. Assuming this is it. So whenever you are given a right angle triangle, the trig ratios are three. That is, we have the sine, we have the cosine, and we have the tangent. So how are we going to identify the sine, the cos, and the tan? By what? Now the first thing is, consider your angle 90. The side that is facing angle 90 is called the hypotenuse. That is this place. You see, this long place is now called the hypotenuse. Any side facing the right angle triangle is called the hypotenuse. Also, any side where the given angle is facing is called the opposite. And the remaining side is called the adjacent. This is it. For instance, I might be given an angle like this, and I can say this is a right angle triangle. What normally shows that an angle is a right angle triangle is this, 90 degree. If I say this is 90 degree, this is my angle. So the side which face the 90 degree is called the hypotenuse. The one facing the angle given is called the opposite, while the remaining one is called the adjacent. No matter how the angle is drawn, how to identify is just to say where your 90 is and where the given angle is. So now, having this one, now let's see the trig ratio. The first one is what we call sine. Sine, and we write it in short form of SIN. Sine of the angle, that is sine theta. Sine theta is always given as opposite over hypotenuse. Opposite over hypotenuse. Number 2, cos theta is given as cos adjacent over hypotenuse. Adjacent over hypotenuse. And the last one, which is tan theta, is given as tan opposite over adjacent. Opposite over adjacent. So to simply identify this, we make use of something we call SOHCAHTOA. SOHCAHTOA. This is it will make it easy for you to identify the sine, cos, and tan. Look at it, you just categorize it into three. So, ka, and toa. S stand for sine. C here stand for cos, and T stand for tan. If we take sine of theta, so in front of it we have O and H. O stand for opposite, H stand for hypotenuse, A stand for adjacent. So look at it. Sine theta is equal to opposite and H. Opposite divided by hypotenuse. While cos theta is ka, which is cos, adjacent over hypotenuse. Adjacent and hypotenuse. And tan is toa, T, which is O and A, opposite over adjacent. So this is simply the trigonometric ratio. So after the trigonometric ratio, there are some Identities I might give 2 or 3 that are very, very, very important. I can call identities. Identities. When we said identity, some things that are simple, that are the same, things that are the same. I can say 2 and I can say 6 over 3. So 2 is identical to 6 over 3. When we take a look at this, 2 and 6 over 3 are not the same in terms of looking, but in terms of expression they are the same. Because 6 divided by 3 is the same thing as 2. So therefore 2 and 6 over 3 are identical. So some simple identities I may write here are, number 1, I can say tan of theta is the same thing as sine theta over cos theta. Number 2, there is one identity is very important, which is sine square theta, sine n theta, or cos n theta, or tan n theta. This is the same thing as, sine theta all power n. Number 3, cos of negative theta is the same thing as cos positive theta. Number 4, but sine of negative theta is the same thing as, just take the minus sine theta. If you compare these two, in cos, whenever your theta is negative, and if it is cos, then it's the same thing as positive one. For instance, I may say, what is cos? Minus 30. Just say that it's the same thing as cos 30. Because negative cos turns to positive cos. But if it is sine, the negative is still there. Also in tan, if it is tan, the negative is still there. Another important one is number 5. Look at it. Sine square theta plus cos square theta is equal to 1. This identity is very, very, very important. It's very important. Whenever you are having sine square theta plus cos square theta, it's the same thing as 1. Also, from this one, I can say that sine theta or sine square theta is the same thing as 1 minus cos square theta. Also, if I have cos square theta, it's the same thing as 1 minus sine square theta. These 3 identities are very, very, very important. Let me say from 6, I can produce another one, number 8, from 6 or 7. Look at it. Sine theta is the same thing as root of, because this square, if you take the square root of both sides, the square will go, and here you are going to have the root 1 minus cos square theta. This is very, very important. Also in this number 7, you can make cos theta to be equal to root of 1 minus sine square theta. These trigonometric identities are very, very important. After this, we are going to see inverse of 3 identities. The inverse of 3 identities. Inverse. Number 1, we have what we call cosec theta. This cosec theta is nothing but 1 over sine theta. Sometimes, yes, 1 over sine theta. Number 2 is sec theta, but sec theta is something as 1 over cos theta. The last one is cot theta, which is equal to 1 over tan theta. Also, these trigonometric inverse are very important. Cosec, whenever you see cosec, is something as 1 over sine. It is the inverse of sine. Sec is the inverse of cos, and tan is the inverse of cot is the inverse of tan. Okay, let's see one more example that we can solve using 1 or 2 of these given identities. Example. If sine theta is equal to 5/3 and theta is an acute angle, find A cos theta, B tan theta. Assuming we are given something like this, if sine theta is equal to 5/3 and theta is an acute angle, we all know what is acute angle, an angle 90 degree, or an angle less than 180 but above 90 degree, that is any angle that is in second quadrant. Find, okay, let me use, if theta is right angle, let me use right angle so that right angle triangle, that is angle 90. So we have to find cos theta and tan theta. Now look at it. Solution, we might use our identity number 8, the one that says cos square theta is equal to 1 minus sine square theta. The reason why we are using this one is because sine is already given. So if sine is given, we are using cos. We just substitute the value of sine in our formula. But we say that cos square theta is now the same thing as 1 minus sine square theta in a root. And this is the same thing as what? Sorry, cos theta, taking the root of both sides. We have cos theta is now equal to 1 minus, using that is one of the identity which says if you have n here, you can conclude by saying all square. So we just substitute the value of our sine from the given question. 1 minus sine theta, what is sine theta? 5/3, then you square it. Squaring this one, we are going to have 1 minus 5 square, 25, 3 square here is 9, all in root. Just find the LCM. The LCM is 9. 9 in this one, we have 9. There will be a problem. Let me just change something. My 3 here and 5 here. Because if we go like this, we are going to obtain a negative result, which is invalid, which is complex. But if I change it, we are going to have here is 3 and here is 5. So here is 9 and here is 25. So the LCM is 25 as usual. Having 25 here, we are going to have 25 minus 25 here, 1 into 9. So we are going to have positive results. This is the same thing as 25 minus 9 is 16 divided by this, which is 25. Taking root of 16 is 4. A root of 25 is 5. So this implies our cos theta is equal to 4 divided by 5. Then the second question, which says tan theta. If you recall from the given identity, tan theta can be expressed as sine theta divided by cos theta. Our sine theta is 3 divided by 5, all divided by cos theta, which is 4/5. Now if we reciprocate, we are going to have 3/5 multiplied by 5/4. 5 cancel 5, and at last we have 3 divided by 4. This is very, very simple. But there is an alternative way of finding this, that is using Pythagoras rule. We just use it here.